I know exactly what you're thinking. What if we take one of these technical solutions and really put it to the test? What if we put it underwater? What if we put it in the ocean? Will it be able to do what we want it to do? Well, there's only one way to find out. Let's talk to a customer who had a project that did just that and see how they fared. That's this episode of Dev Radio. Hi, and welcome to the next episode of Microsoft Dev Radio. I'm Jerry Nixon, and I'm here with Terje Nilsen all the way here from Norway. We're going to be talking about an impressive accomplishment by his team and ours through a proof of concept study that is pretty awesome, actually. Terje, thanks for being on the show today.
Thanks for having me.
Now, before we start talking about your company, before we start talking about the solution, tell me a little bit about who you are and where you come from.
So I am, as you said, Terje Nilsen. I am the manager of the disruptive technology in Kongsberg. So Kongsberg is in Norway, a very large company compared to the US companies, not that big, but compared to the Norwegian ones, it's huge. We are into all kind of businesses. And my background is software engineering, so I am a master in software. And yeah, I did some classes at Stanford, but never actually graded there, so I went back to Norway, worked in Silicon Valley for a while. That was cool. And so now I'm back in Norway.
Nice. You've been around the world. So now you are, that's pretty inspiring by itself. A software developer can become the manager of disruptive technology. What's the subtext there? What are you really managing?
So what we are doing is we are experimenting on new technologies to see if we can disrupt some market parts. So that means we can take what is new on the market now, can I put that together with someone else made something new, make a new project and say, okay, this is cool, like the port monitoring. And we have also tons of other things, like in the drone business and other businesses. There's a lot of things we can do just by taking the latest of technology that already exists, put it together with something else that exists and introduce it to a new market.
That's
awesome. Basically get to play all day having fun, you know.
Yeah, I totally get it. That's awesome. And you have all this at your disposal with such a large company behind you. And so we're going to be talking about port monitoring, but let's look at the future for a second. If you're going to disrupt an industry, what's the next industry on the chopping block? Because when I look back in history and I look at all the industry, there was a time 10 years ago when every single industry was ripe for the picking. Everything was ready to be technologically revamped, and I almost feel like we're at a new season where they're ready to be upgraded. But besides all that, what's in, if you were to guess the next industry that was about to be disrupted, what's in your goggles?
I think then we will use worker drones and Azure cloud to disrupt inspection, building inspection, ship inspection, you know, everything that's a risk. Windmills, everything where there's something that's hard to get to.
Yeah.
You will have drones, but not game drones, but worker drones. Drones that are designed for a specific need, and they will send the data to the cloud. And then we can use the Azure machine learning kind of part to figure out is the building okay or not. And then, of course, the customer will just get, oh, the building checks out, or glass number 5 needs to be changed. You know, you don't need to have 5 hours of video. You just get the result as a service. And I think that is really coming because everyone's into drones, but everyone's doing it just for fun. Now we need to make the worker drones. Now we need to make something that actually do something. And that's
worker drones.
Things. Yeah, it's going to be a huge thing.
It's a good differentiator, the worker drone versus that fun Phantom that everybody just zips around mountains taking pictures of. That's I see it too. I have to admit, Terje, I'm a little nervous. It's a scary future a little bit because we're going to have drones checking my piping around my house, and all of a sudden I'm going to look out the window and there's a drone checking out whether or not I need a new tile on my roof or not. And it's very efficient, but it seems a little creepy too.
Isn't it more creepy if there's a guy knocking on a window or something, climbing up the window and try to look at what's going on? I don't know.
You got me. I guess so. Yeah. Okay, but that's not what we're talking about. But it is fascinating, and it's neat to be able to talk to somebody who thinks about this stuff all the time. And I can only imagine all the different things you must have your fingers in, but that's not what this is. So let's talk about Kongsberg. Kongsberg is a large company inside Norway. They've got their hands in all kinds of different industries. Let's talk about this industry. What's the industry in this project where we're headed right now?
So right now we're in the subsea industry. So the subsea is positioning, it's acoustic monitoring. We can have acoustic monitoring on the seabed to look for pipes, look for leaks, we look for these kind of things. We have DP systems, that means we can have ships staying put at one position at a time, all these kind of things. So it's monitoring, so we just call it environmental monitoring, but it also monitors everything else. And in this case, specifically, we are monitoring the seabed in ports and also the water inlet. And the main reason for this is we want the ship to be able to fill as much cargo as possible. And the draft, of course, of the boat will be higher and higher the more you fill into the boat. And at some point, it's going to get into the seabed and you get stuck. And this changes because if you have if there's spring and there's a lot of water coming in from the lakes, you get sand, and then all of a sudden the port is 1 meter more shallow, and then you have to have 1 meter less of cargo on your ships. Mm-hmm. So the idea here is to monitor this live all the time, so that we at any time know how much can you actually put into your ship and still be able to get into the port. And
well, without a system like this, then what's the alternative? We just play it safe, and we're like, well, we measured this last week. We think some things may be changed. Let's not fill this thing full so we don't get into trouble. Or let's fill it full, and now we are into trouble.
But the problem is it's not last week. It's the last 6 months. So that's the thing today. So they are planning ahead 6 months all the time. So what can happen during 6 months? You know, so they have to be super conservative. So they have to be several meters about what could have been. So they lose a lot of money on that. But that's the only system they have at the moment. There's no alternative.
Wow. And then in comes a disruptive technology that sets it all straight. It's kind of funny. We start by talking about worker drones in the air being able to see things that are typically difficult to see. And now we're talking about things underwater seeing things that are typically difficult to see as well. Part of the problem is we just can't, you can't just look into the water, right? Everything's not perfectly clear, and there's all kinds of other reasons. What are some of the different technologies that you're employing to be able to see? I heard you say acoustic, but talk me through some of the different things that allow me to, I guess, have vision under the water.
Right. So we use sonars, which actually sends out an echo ping. Listen for the returning echo from that. You can actually, it's amazing though, you can actually draw a picture of how the seabed looks, like in a three-dimensional point cloud, just by looking at your ping, that ping you sent. And the computers are doing this live, and it's just so cool. And you can have several of these up on the base, and you can see the entire surface, just like there was no water there at all. You can see all the details. And from this, you can calculate where is the highest top, where is the lowest, how did it move, where is the problem areas, and you can do all that. And of course, Kongsberg also has the AUVs, which is kind of cool, which is the underwater autonomous vehicles. So it's the same as a drone, but now it's a drone on the water.
Yeah.
And you can swim around and just look at, because, you know, in a port, sometimes people lose something. They lose a container off the ship, and it ends up on the seabed. And now the question is, how safe is it now to go there? Or how deep is it now? You know, you don't want to hit that container. You need to send someone out there to check out what's the status. And that's what we can do with our systems continuously. And then a lot of the systems are already using Kongsberg echo sounders on the ship. So our idea is to connect that to the cloud also, so that when it comes in a ship, they use their already onboard equipment to check the seabed. So that we can give that to the next boat coming behind it, you know, and then if we do that with all the boats we have equipment on, all of a sudden we can draw a picture of how it looks like, not 6 months ago, but maybe a few hours ago, you know, and that's more important.
And then, of course, I suppose they get to use... No, keep going.
So if there's something danger, the next boat will just stop and wait until we have removed it, which I think could be a very good thing rather than just, you know, hitting it.
Through it. Yeah. Well, of course it is. Absolutely it is. Wow, this is incredible, actually. Do they get to use, let's see, what did you call it? The echo sounder? Is that what you called it? Is if I have that on my ship, I suppose I even have the advantage of using that when I'm not in port. I come into port, the seabed is high fidelity. Because there's so many things taking a picture, and I get to use that as I'm kind of working my way out as well. Wow, this is fascinating. Truly, it is fascinating. I just read an article that said annually the shipping industry loses 10,000 shipping containers. 10,000 every year. It's a massive.
Imagine.
I mean, they're so big. It's like two of them would make my house kind of thing. It's crazy.
But the strange thing, though, is that, so then you would think this must be an immediate success, right? It's like, what is the flaw?
Right.
And the flaw is the shipping companies actually plan their shipping 6 months ahead.
Uh-huh.
So if I can give you the latest information that's from yesterday, but you already planned your ship 6 months ago, then you already filled up your cargo,
Yeah.
and so now what we need to do is we need to put all this onto the cloud. We need to actually make it a service so that people can start also doing their shipping planning on a different level. So it doesn't matter if we can disrupt just one small part of the market. We need to take a bigger part of the market so that we can also do the planning, because now we need to have the planning more agile, more like we are planning now. The ship is leaving in 2 hours. How much can I actually fill up? Because I'm going to be there all tomorrow,
Let me ask you something. I know that daily weather is not very reliable, but if you look at weather over a year, it seems like there's patterns. How reliable is the behavior of the sea, and how reliable is the behavior of sediment and things that move and come and go into a port? Do you anticipate someday you'll build a model that's able to show the ongoing pattern of what's going on under the sea and then predict what's going to be next year the same time?
If you have enough data, it might be possible. Then you're talking big data, and then we're talking the artificial intelligence built into Azure, right? Now, because now we need to do in background working on the big data. But after 1 year recording, no, you can't do that. Maybe not even after 5, but maybe after 10 years, because this is trends, and you need to look at the trend. And 1 year there's a storm, the next year there's no storm, and storm actually moves sand a lot around in the rivers. So it's hard. But if you can. And that's the cool thing about data mining, if you can look into the data, if you have a lot of data and you say that, oh, well, there was a storm that year, and then we got this happening, and all of a sudden you have something, and then if you find a correlation, you can say, next year, I think we're going to have this. Maybe.
So it's complicated is what you're saying.
It's really complicated.
All right, let's get back to this berth depth and being able to monitor this. Do you already have this implemented in a port in Norway?
Not in Norway and U.S.
Oh.
What was the port? Is it in Seattle or something? Somewhere around Seattle area.
Okay.
That was the cool thing when we were in Madrid on the Hack Fest, because it's a small embedded computer like a Moxa, just and it's a Linux computer, just like this inside a box, and it's doing the monitoring, and it wasn't running anything like Azure at all. It was completely running something else, and it has a cell phone, and all it has is a cell phone interface. So I was sitting in Madrid, and I was logging into this remotely over SSH, and then I installed all the Azure software on that while I was logging in. It was kind of cool. And then I installed the compilers and everything, because I couldn't cross-compile from my Mac, because I was running Azure on my Macintosh, and there was a Linux system, and we were on a Windows hackathon. It was really cool. So I got everything installed down there, and I made a software running on the Mac first, then I took the source code up there, recompiled it, and it was running. And after 2 days, we were actually getting live data from the seabed onto the cloud, and the other guys working on the three-dimensional module, they were then able to actually to plot it so we could see how it would look and all this. And
you make it sound pretty easy all of a sudden.
But if it hadn't been for that Microsoft event, I don't think we would have made it, because when you have all the experts in the room, you're sitting there.
Yeah.
On my table, there was 2 experts already, and in the room, I guess there was maybe 10 or 20. And every time you had an issue, there was someone who knew the answer. And even if we were running it on embedded Linux, which hasn't been tested that much, there was a lot of small bugs and dependencies nobody knew about. But still, when you're there, all the experts working back to back, it was so cool. So after 2 days, we had it running. The third days, we did some demo thing, and it was just great. And Yeah, I mean, then it was working on the Windows system, on the Mac system, and then the small embedded Linux system, and we even compiled it on the system itself over the cell phone line on a live system on the bridge.
What can't we do in this modern world? Man, it's absolutely incredible. And it all seems like impossible, and then all of a sudden it's so simple. Hey, talk to me just a little bit about the device. This is pretty fascinating to me. It has some sort of cellular transceiver in it. Can you get a cell signal underwater, or does it have a floating antenna, or how do you do something like that?
Okay, so in this case, that is actually a very fascinating question, which we are struggling with every day. But in this case, we mounted it on the berth itself. So the sonar underwater, a few meters underwater, but there's a cable going up, and there's a watertight box on top in air, which has a cellular phone, which can communicate. But when we are doing like tsunami warnings, then we have this issue actually that you're measuring, because we have the same sonar or similar things sitting on the seabed. How do you communicate that to the cloud? You know, you're in the seabed, there's radio signals. So then we have to have buoys with cables. We have to have acoustic communication. These days we can actually communicate using sound in water, just like the whales are doing it. And then we can have satcoms floating on top of the water, and then I can send it to the cloud. So it's feasible, but there's a lot of things around that, and it's very, very fascinating.
Very complicated.
Yeah,
very complicated problem. This is why these problems remain a problem. Because they don't have such a simple solution where you just drop it in and it's done. I would think, I'm not in any kind of maritime industry, obviously, but looking at it, I would say, wow, this has been around for 2,000 years. All of these problems, I'm sure, are solved. This is all done, and it's amazing to see. In fact, it's amazing for me to see every industry is like this. Every industry still has these lingering problems that it just turns out the speed of light is not fast enough. It just turns out that material things degrade too quickly in different environments. It just turns out all of these different things, and then we start introducing new things to them. You're like, wow, now that you've barely got a solution in place, it sure would be great if we could get that more real time. Boy, it sure would be great if we could make it secure so people don't hack into it. It sure would be, and we have all these extra requirements where we're just by a shoestring, we're barely solving all of these problems as it is. It's fascinating to me that here we are in the year 17, and we're still like solving things in a very early stage still. We're still a very elementary set of solutions. Even when you look at things like rocket science, even that, there's a lot of duct tape being used in that type of industry to get things fixed. And it's fascinating, absolutely fascinating to me.
And also I think it's fascinating that if you look at the movies, what Hollywood is doing, and then you compare it to the real life, like everyone thinks that if you have a submarine that's going really deep and you have a boat on top, you can just send live video up, right? Because you do that on all the movies. That technology doesn't exist yet. There's no way to get the video from the subsea down up to the boat. We are working on that these days, and it doesn't exist. So it's kind of interesting.
Yeah, it's fascinating. You wonder who these technical advisors on these movies are. Obviously, people who watch other movies instead of actual scientists. Talk to me a little bit about the culture, the technical culture in Norway. What's going on in Norway technologically right now? Do you feel like you're in a center of technology in the world?
In the center, probably not right in the center, but we're coping pretty well, right? It turns out we're slightly behind on the cloud kind of thing because we still have the discussion where it's safe or not. And so a lot of companies still haven't moved over to have their data on the cloud. They still have the hard drives and all these kind of things. And we're in the middle now of the transition there. So that will happen over the next year.
Well, wait a second, Terje. Help me. Let's pretend we're at a conference together. We're in a conference room, and you're convincing me of this cloud solution because of machine learning. And I say, is the cloud even safe? How do you respond to that concern?
So my response is, if you have a hard drive, number one, it can easily be stolen. Number two, we know it's going to fail within 5 years. Are you prepared for that? Do you have a backup? Do you have a solution? Do you have an IT infrastructure that can cope with that? If it's on the cloud, someone else is taking care of that. They are looking at wear leveling. They are changing the hard drives on time. They
Yeah.
are making sure that the data doesn't get lost. There's no way to break into the cloud because the cloud is kind of virtual and you have to break into several places at the same time. So it's kind of safe. The only thing that's not that as questionable is how do you save your password? But that's up to you, you know? So I think
Yeah.
the thing is, how safe is your password? Did you figure it out by using your name and a number behind it? Because that's everyone's doing that. Or is it really a safe password? And where do you keep it? And I think that's where we need to work on it because it's the cloud, you know. And then, of course, it's the media who's always kind of pushing it the wrong way by saying that, oh, WikiLeaks got the hold of all this kind of data by hacking something. But I think that's easier to hack a company right now than it actually is to hack the cloud. We never heard of anyone hacking Azure cloud, as far as I know. So I think that is way harder than just to hack a company who doesn't really know how to deal with the security. So
Yeah.
so I think that's the future anyhow. And we get all these extra things that you can grow as much as you want. You can start with a small company and all of a sudden you have 100 employees and you have the same cloud, right? You just order more drives or more hard drives. You don't need to rescale. That's kind of cool. And also you can do the background machine learning kind of things, which I really like because I'm a sensor guy. I collect data from all over the world. And if you connect all the kind of data, you get into big data problems, and big data problem is that it's going to take too long to go through all the data. You're going to sit there, not wait for a coffee anymore. You're probably going to sit there for days and weeks before you get the results. If you can do it in the cloud, it's just a matter of how much you want to pay. I can have 1,000 computers looking through all the data, see if they can find something I was looking for. I think that is the future. And if you don't have the data on the cloud, then it's how do you get, then you're stuck.
I think the cloud is another disruption for sure, probably one of the most significant disruptions in our generation probably, that has kind of messed up the way that we all learned how to build systems and protect systems and even build companies. It's pretty fascinating. Let's back up to your solution just for a second. Your device was a Linux device, or it was running Linux, right? And we had an SDK for that. Tell me a little bit about your... when you went into this, were you expecting for the Microsoft Cloud to support all of the non-Microsoft technologies as much as we do?
Not really, and we had a joke of that because when I got to the Hackfest, which was my kind of introduction to this, the first thing I told the guys there was I'm going to run on a Mac because I only use Mac. And they say, no problem. And I was expecting a different answer, and all of a sudden Microsoft is saying, we don't care. You can use Mac, you can use Linux. And then we were talking about an embedded Linux. Embedded Linux is quite complicated. There's no C# or anything there, it's only just C++. How do you get it to work? And then it turns out they have an SDK for that, which doesn't even use C++, it's regular C, so you can run it on anything. And then we were thinking, okay, but how do you compile it on embedded Linux? That's always tricky with all this dependency and all that. And it turns out that it took a few hours to get the dependency worked out, but it was actually a lot smoother than I thought. And all of a sudden, I was pushing data to the cloud through the secure link using IoT and even event tubbing. And that was surprisingly easy when you got, but of course you had these super experts around you, which really helps though. So, and then also when I did it on the Mac, I used the Xcode, which is a compiler on Macs, and that was surprising that was so easy because I didn't expect that to just work. So then, because then I had some extra time, then I tried it on Qt just to see if it works on that also, and that also worked. So it's kind of cool, and you can use it for anything now.
All of these pieces, it is amazing to me that the requirement to have a proprietary line of technology is kind of in the past, and now we realize that, honestly, companies like, Kongsberg and others have already made significant investments in hardware and other technologies that, if we were to turn around and say, okay, now we need you to change to everything we support, all of a sudden that's just unrealistic, right? It's just it's not good business anymore for sure.
I agree. I agree.
So now we have that. Now I'm picturing Marco. Marco works in, let's say, Spain, and he is listening to everything you're saying because his company, even though it has nothing to do with anything in water, they have a very similar scenario, and they kind of want to pull off what you've pulled off, what would you say to Marco? Like, how could he get started? Because he's not going to a Hackfest, but he knows that there's some things out there that you've probably discovered. What would you say to a developer who's watching who wants to kind of do what you've done?
Okay, so it's actually quite simple. You go on the net, and there's two things you need to search for. First, of course, you need to figure out, do I want to make an IoT device, or do I want to make just an event hub? So the event hub, you just push data, and you don't need anything back. On the IoT, you can get actually data back, and you have something called parallel twins that means you can get configuration. So you need to consider which one. Then you go on to Google, or Bing, or whatever you want to search on.
That's
exactly. and then you search for Azure IoT C++ embedded, and you come directly into the page that Microsoft made, and it has a nice description of how you do everything, and in the bottom you download the SDK. And when you download the SDK, assuming that you know a few things about Linux compilation, you will be able to make it work within a few hours. There's always some dependencies because they are using the SSH for secure communication, so you need that library, and you're going to get stuck on that library because they need the development version of it. And there's also another library that you will look into it and you will see it, and you need to add a couple of libraries, and when you've done that, you will be able to compile it, and then it's just going to run. And yet, the only thing you will also notice, which I think Microsoft should work some on, is the examples are a little too complicated for the very first beginner. I mean, if you have an SDK and you have a bunch of examples, these are good, but you could have made the examples even simpler. So what I did was I took the simplest example and I made another software on top of that just to abstract even more. Because all you actually need is you need to open the connection, you need to write the data, and close the connection. You could have made it in open, write, close, and with a few parameters, which is the key, the SAS key, and these kind of things. So it could have been, but rather than that, it's like 50 lines of code that you need to kind of understand, and then you can make it run. However, the thousands of lines of code are abstracted because they're already in the SDK. You don't need to think about it. And once you start to read out the SDK, it's kind of simple. It's kind of okay to use. And I got it to work quite quick, and I just used named pipes for the communication, and then it was super simple because if you use a named pipe, you can take any other software and just pipe the data directly to the Azure, and that worked quite well actually. But do expect a little time. Don't think it's going to do it in 10 minutes because it's Linux, it always takes a little extra.
And you did it in 3 days, so without 20 experts sitting around you, it might take me a week or so and a lot more Googling to be able to find all the answers that maybe I need to. But the more important part is, this isn't a 6-month science project to try and see if we can get this to work. It is something you could probably turn around in a somewhat short sprint or something like that you have at your team. You can send a couple of developers to try this out. Talk to me about the overall solution. What do you see as far as taking what you've discovered here with this proof of concept and implementing it into your real products? Is that something you see coming forward?
Yeah, exactly. Yeah, I do. So in the beginning, I didn't know if this was something or just a hype. And then I started to work with it, and I am also working in a project called Ocean Farming, where we'll make the world's largest fish farm. 110 meter in diameter, is larger than the oil platforms, just to harvest fish or to have salmon. And there's a lot of sensor in that because we want to make sure that the salmon is feeling good, and then it grows and all these kind of things. And that's going to be big data. After a few years, after collecting this data for a few years to get some trends, we're going to have a huge amount of data. How do we process this data? Where do we store the data? This has been a big issue. Now that we have Azure, we can push all this data to the cloud. And then we can have the cloud looking for correlations, because what data mining is all about is finding new correlations. So if I look at the temperature on the water, the salinity on the water, how much the fish is actually growing, maybe I can find new correlation. Maybe they got too much feed or too little feed. So I can actually tell the farmer that you need to do these changes to have a more optimum kind of grow of the fish or whatever you want. But you can only do this trending over a long time, because if you measure just like one cycle, that could be that one cycle, but next cycle could be something completely different. But you can do it over a lot of cycles, and you have your artificial intelligence looking at all this data and trying to figure out where is the correlation, what happened, why did that do, and then after a while, I think we can actually give them pretty good suggestions, and there's a huge project in knowing going on right now, and people are putting in a lot of money into this, so it's going to be cool.
Yeah, sounds delicious.
And that's just one of the things. Of course, I'm from the drone industry originally, so I really like the drone part, and I think also there we really need the Azure or similar clouds, because we want to collect all the data from these worker drones I talked about and get it into the cloud so that the cloud can do the post-processing, and then we can deliver data as a service. If you're inspecting a glass facade on a huge building, rather than climbing around, you take the drone, you go up, down, up, down. They're really good at this, boring job going up, down, up, down. But that's going to be like 5 hours of video. Who's going to watch the 5 hours of video? Now is where you need your solution on the cloud, the computer will look through the video and look for defect and say Windows number 451 needs to replace, Windows number 265 is broken, but the rest was okay. And then you have 2 small pictures you need to consider about rather than hours. And I think that's the future. And you can do that with everything. You can do it with houses, building, boats, ships, I don't know, whatever.
Well, as data grows and we have just so much data, the upside to it, I think, is that we're able to ask questions against that data we've never had before. Like when we were talking about the behavior of the sea, maybe with a decade's worth of data, we can start to ask for patterns that are bigger than we expected. Maybe not. I don't know. Only having that data is what's going to tell us, and only being able to measure that data are we going to get it in the first place. And so it's funny how we have this, almost virtuous cycle of if you do this, then you get that, then you get this. But that gives you even more. And so it's just one of those strange things where we need people like you to be able to have the foresight to say, here are the things we need to measure, because even though we're dropping this thing in so we can see the seafloor, it'd be really great if we also knew the temperature. And it'd be really great if we also knew, and just fill in the blank, right? There's so many things that you could measure.
But not only that,
it may not have an immediate business case.
Yeah, and I think also in the future there will be business cases just buying data from others. If you collect a lot of data about sea temperature, someone else who is not interested in the sea temperature but they're interested in something else, birds or whatever, they will want to buy your data, because then they can put that into their Azure cloud. And then if you buy data from a lot of companies, you can get a new picture, right? So all of a sudden, you're not looking at the berth monitoring, but you look at how sand is moving in rivers or whatever, and all of a sudden you can just get our data plus some other guy's data, and then you can put together a new picture, and you can deliver that as a service to the third guy who wants something.
Now, we know that we have a lot of data, and we're pushing it into the cloud. How do you deliver it? Like, what are your customers? What do you anticipate your customers being able to see on the other side? Raw data, or just, is it going to be I don't know. You tell me.
So we are deep into process data. We don't think the raw data it's not. No, it doesn't work, because then the customer has to actually understand the equipment. They have to understand how the sensor actually works. That doesn't work. We have to post-process the data so it's understandable. And what we are working on now, and I have a bigger department working on, is how can we make like 3-dimensional viewing of the data? How can we make like easy to see things? So if we can project the data in a very easy to understand way, they don't need to know that behind there's a lot of numbers and a lot of math and all these kind of things. All they can see is just a result. They can, if they're inspecting a ship on the seabed who has gone down, they want to see the ship, right? They don't want to have all the data and the point clouds and all this. That doesn't make sense to them. And also we just purchased a huge part in a company who's doing power line inspection, power grid inspection. So they're just using a drone and they fly around the power grid and they're looking at it and see if there's something wrong with the isolator. But they don't need to send all the data back to the power grid owner. They just say that isolator 4000 needs to be replaced and 2000 need to be replaced, and the rest the drones have to do themselves. And I think that's the thing you need to do. You need to take the video, process it, and then just give the result, like 5-minute clip, and this is what we saw. We think it's strange. But of course you cannot do that manually yourself. You have to have the computers doing this so that there's no labor into it. You just stream in the data, make it do your job, and get it back. And I think still we're not quite there in a lot of business industries, but over the next 10 years, we're going to see a lot of growth in that. Things are going to get so much smarter. The computer will actually be able to tell us so much more about what is the status of this. Is this okay or not?
And
for
yeah, I'll tell you what's funny, Terje, what the coolest part is what you're talking about isn't science fiction. It's just allowing the data to catch up. It's allowing our models to catch up, right? It's not, can the cloud execute this much computation? Of course it can. We just haven't built those models yet because we don't have that data yet. And we're waiting for business to catch up, for monitoring to catch up, and really just to be able to have this almost, there's a threshold we need to cross where the data is, and then suddenly all of this is sort of sitting. This is fascinating. This whole birth monitoring system is fascinating. I'm so glad you were able to come to this Hackfest and work with us. I'm super happy you had a great experience as well. This has been a pretty fascinating conversation. Thanks a lot for taking the time and talking to us about it, because I feel like just conversations like this, somebody who's watching this show, they're like, man, I'll never be in the birth monitoring, it doesn't matter. I mean, everything has such a relationship. I'm going to build a system that monitors tree growth, and it is going to be very similar to your system when I'm done, because in the end, these technologies are the same technologies. You're just implementing it in a different way. Sure, yours is underwater. Sure, yours uses cell phone or whatever, right? And It's pretty neat to be able to see, wow, here it is. It's on a massive scale, and it actually works, right? This isn't just a marketing video where we're like, oh, someday it'll work, and here's the dream. There is something there. Thanks, Terje. I appreciate this conversation. Anything you want to leave here in closing?
That is always difficult. No, I think I pass, The famous last words. No.
Famous last words, that's right. All right. Well, thanks. I appreciate you being on the call.
Thank you so much.
We'll
Bye.
talk to you again.